Hello everyone, I'm Takamitsu Tajima of Honda R&D. My presentation today will concern side conductive electric load system for heavy-duty trucks to EVs. My presentation will follow the order shown here. I will begin by discussing the background and the aim of our research in order to provide an overview. Looking first at the background, our research, the achievement of zero emission during vehicle operation will be an important factor in our efforts towards the realization of zero CO2 societies. Vehicles that operate using motor power alone and do not use generators employing fossil fuels as a source of energy will be essential to the achievement of this goal. We therefore believe that evolution of EV and FCV will be a key focus. However, the EV presents a number of resource issues, the main being cruising range, charging, and a decline in dynamic performance due to increased vehicle weight. We believe that there are broadly two ways to address these EV-related issues. One is to boost battery performance or to increase the number of batteries fitted to vehicles. The other is to supply power to or charge the vehicles while they are in operation, that is, to realize electric load system. Now, I would like to describe ERS. This means that battery installation can be reduced to 1/10 the amount. In other words, the production of lithium-ion batteries can be continued 10 times longer. This was the background to our development of the high-power ERS that I will be discussing today. The aim of our research was to realize unlimited driving range for EVs by charging the vehicle using large amount of power while they are in operation. The realization of unlimited driving range in this way would offer users freedom to operate the vehicle and to stop and get out just as they please, without the constraint imposed by the necessity on charging. Today I'll be discussing a ERS 150 km per hour using a power of 450 kilowatts, a DC voltage of 750 volts and a current of 600 ampere. This table compares different methods of ERS. Wires type and conductive type charging methods are compared. Based on these considerations, we decided that a conductive type system that supplies power from the side would represent the most effective system. Let's look at this system overview in greater detail. The pink sections here present technologies that had not previously existed. DC power is supplied to the ERS lane from the high-capacity storage battery. The ERS lane supplies DC power to the vehicle. On the vehicle side, the power is collected by the power collection unit and provided to the operating motor and battery simultaneously by the dynamic charger. Each of these systems is controlled by an integrated control ECU. Let's look at this system overview in greater detail. The pink section here represents technologies that had not previously existed. DC power is supplied to the ERS lane from the high-capacity storage battery. The ERS lane supplies DC power to the vehicle. On the vehicle side, the power is collected by the power collection unit and provided the operating motor and the battery simultaneously by the dynamic charger. Each of these systems is controlled by an integrated control ECU. Next, I will consider the associated infrastructure. The ERS lane can be created by mounting trolley wires on an existing guard wire. The screen shows a magnified view of positive and negative trolley wires attached to the guardrail in a V-shaped configuration. Protective covers made up of insulators and insulating materials are fitted around the trolley wires. Simply by pushing from the side against the trolley wires in their V-shaped arrangement, the power collection unit height is centered and the rollers make the desired contact. We have applied Japanese rail safety standards. To continue, I will look at our prototype vehicles. We created 5 prototype models. Today, however, our Type 4 prototype vehicle will be the main focus. Type 3 and Type 4 are able to charge using a power of 450 kilowatts at a DC voltage of 750 volts and a current of 600 ampere at a vehicle speed of 150 kilometers per hour. I will now discuss Type 4 in greater detail. This is the Type 4 prototype. These are the main systems making up the dynamic charging EV. This heavy-duty truck has 350 kilowatts of power. Type 4 is able to charging using a power of 450 kilowatts at a DC voltage of 750 volts and a current of 600 ampere at a big speed of 80 kilometers per hour. By optimizing the contact pressure and the dynamic charger control. By intermittently charging the vehicle while driving, it becomes possible to achieve an infinite EV cruising range. Next, I will consider the associated test course. We are carrying out the learning test at the JARI, Japan Automobile Research Institute. The vehicle enters the ERS lane and the power collection unit makes contact with the conductor rails. When this contact is made, the tip of the power collection unit detects the voltage and the ERS begins function charging the vehicle. When charging is complete, the driver is able to freely resume the desired driving pattern. This is a stationary charging system. I will now consider the future outlook for this technology. The goals of our research is promotion of substitution of internal combustion engine vehicles and realization of carbon-free societies by ERS. I'd like to establish the basic technology and aim for real social justice to develop and put into practical use technology of race and the general society. Here we see an image of the future of this technology. In the future, high-capacity storage batteries will be charged using recycled energy and will supply this energy to the ERS charging lanes. In addition, multiple vehicles will be able to dynamically charge in the same lane. Finally, I'd like to explain about merits of Honda ERS. Merits are reduction of onboard batteries, 1/10 the amount, and ultra-fast charging, 450 kilowatt charge. That brings me to my conclusion. Allow me to sum up my presentation. Infrastructure and vehicle system able to realize ultra-high power and high vehicle speed ERS were developed. Simulations of ERS illustrated the condition for realizing unlimited driving distance for EV using ERS. In the future, we intended to continue efforts to further increase vehicle lineup and boost the reliability and safety of the ERS, attempting to realize practical application of the system at an early stage by increasing its power. Thank you for your attention.